Section 1.1 is entitled What is a Function? And we are continuing our review of pre-calculus, and most of this should be pretty basic, so let's see what we can do here. First of all, a function describes how one quantity depends upon another quantity. A function is a rule or set of instructions that specifies how the value of one quantity, the input, determines the value of the second quantity, the output. The input is the domain or x value. The output is the range or the y value. We put in x's into an equation to get out y values. Don't forget to pause when you need in order to get everything written down. I'm just going to continue through the slides, so it's you'll need to pause it frequently in order to get the content written onto your notes. Example, the area of a circle depends on the radius. We all know that we can calculate the area of a circle if we are given a radius. So the output here depends on the input. That's always the case. The area in my specific instance depends on the radius. So the area is the output, or the y value, that is determined by putting in the radius, which is our x value. Algebraically, we would write it like this, that A is a function of r, area is a function of the radius. So A of r equals pi r squared, and that tells us how we calculate the area when we know the radius. All right, so in calculus there are four ways that we use to describe a function. The first is verbally, just using verbal language, using words. The second is algebraically, using algebraic language. That means using equations. The third way is graphically, using a visual depiction, and numerically, using numbers. So the four ways of describing a function, and you will need to be able to do all four of these as we move through the year. So here's an example. A verbal description of a function could be something like, y is a function of 2 times the value of x minus 1. Now if we want to change this to an algebraic description or an equation, give yourself a second and see if you can do that. Can you change this verbal sentence to an algebraic sentence? Hopefully you came up with this, y equals 2x minus 1, 2 times the value of x minus 1. The next means would be by a graphical. So here's a graph, and there's the graph of 2x minus 1. And the last would be numeric, and in this case I chose to do it with a table of values. You could also do it with some ordered pairs, whatever way you would like. You could also say something like, you could even say f of 0 equals negative 1. So different ways to show it numerically. All right, domain, range, and zeros. 3 things that we always need to be able to determine when we're looking at functions. The domain is the set of all input values, in other words, my x values. The range is the set of all possible outputs, or y's. And the zeros are the set of all input values, x values, that make the function value, our y, or our output, equal to 0, also called x-intercepts. So any group of ordered pairs that start with a 0 and then have a y value that pairs with that. And we should be able to find range, domain, and zeros of any function. So I'm going to look for a minute before we get into this a little bit further. We're going to look at some of our parent functions. Oh, that's cut off a teeny bit. I apologize. There is a constant function where f of x equals a number. In this case, y or f of x equals 2. Linear functions. This is the parent function going through 0, 0, where y equals x. Absolute value function has a v shape. Quadratic, we know. Square root, we should be familiar with. Cubic, cube root. Rational functions, or also sometimes called reciprocal or inverse functions. This is a rational with an x squared, so it looks like this. Logarithmic functions, exponential functions, step function, which hopefully you've seen, and then our trig functions, sine, cosine, and tangent. This is one sample of parent functions, ones that you should be familiar with. So when we're talking about range, domain, and zeros, some of these functions, when you see them, they should let you know what kind of range and domain you might have. So linear functions all have an infinite range and domain. In other words, all real numbers are inclusive in the range and domain, whereas absolute value and quadratic always have a limited range. The domain is still all reals for these two, but the range is limited. The y values, they don't go all the way up and down. We should know that cubics, again, have all real numbers for their range, but a square root does not. A square root's domain is restricted because we can't have negative values underneath the radical. Rational functions often will have vertical asymptotes. Logarithmic and exponentials have restrictions on ranges and domains. Okay, so all of these parent functions, when you see a particular function that we're looking for range and domain, the parent function should give us some idea of how to break down our range, domain, and zeros. All right, so let's try one. Find the domain, range, and zeros of this function. Now, when looking at this, you should know that this is a quadratic function. It is written in vertex form. If you don't remember that, be sure to ask me when we're in class. But the domain of quadratic functions is always all real numbers. I don't know if you've seen that symbol before. All real numbers, or a domain of negative infinity. Whoops. To infinity. Okay, so that's the domain, and we know that just because we know this is a quadratic function. Now we also know, since it is a quadratic function, that the range will be restricted. It will either have a minimum value or a maximum value within the range. So how do we determine that? Well, to find the range of a quadratic, we need to know the vertex, that high or low point, the max or min. So in this case, since this is in vertex form, the vertex here is 1, negative 3. If you don't remember, the vertex form is f of x equals x minus h squared plus k. So my h value is my x value of my vertex, and my k value is the y. So since the vertex here is at 1, negative 3, and I know because the value of the leading coefficient is positive that this opens up, I know that my graph is going to look something like this, and therefore I know that my range based on the vertex is going to be that y has to be greater than or equal to negative 3. I can also write this as, bracket, negative 3 to infinity. So that's my range. Now what about zeros? Anytime a quadratic or a parabola crosses the x-axis, it does so in two places. I can always find my zeros by setting the function value equal to 0. So a 0 is always the value of x when y equals 0. So I set y equal to 0. I'm going to add 3 to both sides. I'm going to take the square root of both sides, so I have plus or minus root 3 equals x minus 1. Hopefully you have more room on your paper. Adding 1 to both sides. These two values are my zeros, so my zeros are 1, x equals 1 plus or minus root 3. So since I knew this was a quadratic, finding my domain, range, and zeros was not too difficult. Now this next one's going to require a calculator. So this function has a lot going on. I've got a cubic function in the beginning, but it's multiplied by a square root function. So the first thing I want to do is get a good picture of this in my calculator. So go ahead and put this in under your y sub 1. Make sure that you use appropriate parentheses, knowing that the square root symbol deals as a parentheses as well, and make sure that all of this is under the radical. So this is all going into your y sub 1. Now I need to know a little bit about this window in order to get a good picture. So I'm going to look at the second part of this in helping me determine my window. It's because a cubic function has an infinite domain and range, but a square root function is limited by what can go under the radical. Now this is an x squared under the radical, so it's going to be a little bit different. But the point is that 4 minus x squared has to be greater than or equal to 0. So let's look at this. Adding the x squared to both sides, 4 has to be greater than or equal to x squared. Taking the square root of both sides, x has to be less than or equal to the square root of 4. Now that can be 2 or minus 2. That means that x has to be between 2 and negative 2. So that's my domain for the second half. This part should not restrict my domain, so that should be good for my domain. So let's go into Window and make my x min negative 2. You might even want to make it negative 3 just so that you can see the whole function really well. Let me go back, sorry. Okay, so let's make it negative 3, and let's make our x max positive 3. And then we need to figure out our y min and our y max. Now, if this is close to 0, then we should be able to figure out something about our y min and y max. Let's first start with just trying some nice easy number like negative 10 to 10 for our min and max, and just see what we get from that. And let's get a graph of that. Take a minute with your calculator and put in a graph. Yeah, I'm seeing that I'm missing a lot at the top and the bottom. So I'm going to go ahead and make my minimum. It looks to me, my graph looks something like this. And it looks to me like it goes way down and goes up a little bit past this, but not a terrible amount past. So let's try and make our down a lot bigger, maybe negative 30, and our max, let's go up to 20. So go back into your window, and let's change our minimum to negative 30, y minimum, and our y max up to 20. And then let's look at the graph again. Oh, I'm getting much better now. So now I've got something that looks like this. And I'm still not quite down low enough. I come up and I flatten out. There's my cubic looking part. Comes up and I barely catch that. So I'm going to go up a little bit more on my max, maybe 25. And I'm going to go down to maybe, I don't know, negative 40 on my min. So do you see what I'm doing? I'm playing around with the window. If you have not done this before and need me to show you this in class, please speak up. All right. Now I've got something that I can see the whole function. Let me get rid of some of this and draw a good graph now of what I have. All right, that's good enough. All right, and you notice that at -2 and 2, I don't quite get there, but I know that those are zeros because I know that those are the values that make this part 0, therefore they would make the whole function 0. So let's see. It's going to be something like this, comes up and flattens out, and then comes up and back down again. All right, so my domain, I've got that good. It goes from -2 to 2. We can do that algebraically in a minute as well. My range, I need a min and a max. So using your calculator and your second calc menu, find the minimum on the left and then the maximum. Pause the video and come on back when you have those values. Okay, so the minimum takes place at a point down here that is at -1.67703, comma -32.23849. So that's my minimum range. My maximum is at 1.78, I can't read my writing, 1.7800364 and 20.243517. So that's my maximum. So my range is approximately from -32.33849 to 20.3517. So there's my range. Here's my domain. Now my zeros, I already know that there's one at 2 and -2. And I can find a 0 again. Go back to your calculator, second calc 0. And my zeros are -2, 2, and 1.0626586. I have 3 zeros, which I would expect from a cubic function. We could have found those algebraically. When I have a 0 equal to 2 factors, I can separate this and say that 0 equals 5x cubed minus 6, or 0 equals 4 minus x squared. Whoops, square root of. This one's fairly easy to solve. Square both sides. Okay, and then we're just taking the square root of that. That gets us our 2 and our -2. This one I can add 6, and then I can take the cube root of 6/5, and this is the only cube root that will get me in between my domain. Okay, there was a lot there. Again, if any of this calculator use, if you could not do that easily by yourself, please let me know and we'll go over it in class. Other than that, that's the end of video 1. It was a little bit long, but I hope you got some good notes. Don't forget to submit them.